Good day everyone. Thanks for watching this educational video about Transformer Oil Test Evaluation Part 2. I am Behshad Saba, Senior Technical Advisor of Holly Frontier Specialty Lubricants in Ontario, Canada. Transformer Oil Gas Analysis ASTM 3612 and IEEE C57.104. Dissolved gas analysis is for early failure detection in transformers. ASTM 3612 deals with the methods for sampling, and IEEE C57.104 deals with interpretation of free and dissolved gas in the oil for electrical equipment such as power and instrument transformers and oil field cables. Transformer oils under abnormal electrical or thermal stresses break down to liberate small quantities of gas. The qualitative composition of breakdown gases is dependent upon the type of the fault. By means of dissolved gas analysis (DGA), it is possible to distinguish faults such as partial discharge, overheating, and arcing in a great variety of oil field equipment. There are transformer oils in the market with negative gassing property which will absorb H2 or hydrogen gas into the oil. Using this type of chemistry, we reduce the maintenance operation and cost of the transformers. Partial discharges. Partial discharges is the ionization of a fluid surrounding a conductor that is electrically energized. Low energy electrical discharges produce hydrogen and methane with small quantities of ethane and ethylene. Comparable amounts of carbon monoxide and dioxide may result. Please note that methane and ethane are generated at temperatures between 300 to 500 Celsius. The signature or the key gas generated by partial discharge is hydrogen. A School of Industrial Engineering, University of Cantabria, Spain, generated this graph and the other two graphs in the next two slides. Overheated oil. Overheating will decompose the oil, and as a result it generates ethylene and methane together with the small quantities of hydrogen and ethane. Trace of acetylene may be formed if the fault is severe or involves electrical contacts. Methane and ethane are generated at temperatures between 300 to 500 Celsius, and ethylene is generated at more excessive temperatures, more than 500 Celsius. The signature or key gas of overheated oil is ethylene. Arcing. Arcing produces large amount of hydrogen and acetylene with minor quantities of methane and ethylene. Carbon dioxide and carbon monoxide will also be formed if the fault involves cellulose. It may also result as thermal decomposition of cellulose. Cellulose are used to protect the internal part of transformers, so any sort of the cellulose degradation will be detected during the oil sampling and monitoring. The arcing may carbonize the oil. The signature or the key gas of arcing is acetylene. Arcing is the most significant transformer fault. Any detection of acetylene more than 2 ppm must be investigated. To generate acetylene, oil temperature reaches more than 700 Celsius, indicating a major electrical discharge. Other gases. Other different issues will have their own specific signature, which are different gases at higher detection levels. Methane will be generated as a result of some sparking. If we have a hot spot and it creates the local oil overheating, we will see the ethane generation. CO and CO2 are generated as overall severe overheating of the oil. Sometimes installing an oil cooler can help to ease this issue. Oxygen and nitrogen gases are the indication of air internment. Interpretation of DGA is more of an art than an exact science. There are many guidelines to take actions based on the detected gas levels. So make sure that you will contact with the equipment manufacturer and your oil supplier for more details. Thank you for watching this educational video on Transformer Oil Test Evaluation Part 2. If you require more information, please contact me using my contact details. Thank you and have a great day.